is a part of history that I would like to share about trigonometry. Trigonometry follows a similar path as algebra. It was developed in the ancient Middle East and through trade and immigration moved to Greece, India, medieval Arabia, and finally Europe, where consequently colonialism made it the version most people are taught today. The timeline of trigonometric discovery is complicated by the fact that India and Arabia continued to excel in the study for centuries after the passing of knowledge across cultural borders. For example, Madhava's 1400 discovery of the infinite series of sine was unknown to Europe up through Isaac Newton's independent discovery in 1670. Due to these complications, we'll focus exclusively on the discovery and passage of sine, cosine, and tangent. What is trigonometry? Trigonometry is a branch of mathematics that studies relationship between the sides and angles of triangles. Trigonometry is found all throughout geometry, as every straight-sided shape may be broken into as a collection of triangles. Further still, trigonometry has astoundingly intricate relationships to other branches of mathematics, in particular complex numbers, infinite series, logarithms, and calculus. The word trigonometry is a 16th century Latin derivative from the Greek words for triangle, trigonon, and measure, metron. Though the field emerged in Greece during the 3rd century before Christ, some of the most important contributions, such as the sine function, came from India in the 5th century Anno Domini.
Trigonometry in architecture. In architecture, architects utilize trigonometry designing the structure and parts of the building. Structure height, like angle, and assign intersection angle are all calculated using trigonometry function. Whether you're building an arch, a dome, a ramp, or a bridge, trigonometry will assist the architect in visualizing the result. Trigonometry is useful not just for calculating height, roof slopes, ground surface, and light angle, but also for calculating precision loads and forces. Keep in mind that architects are accountable not just for creating mathematical representation of a designer idea, but also for ensuring that a structure are both functional and secure.
Okay, so this is the third situation that we faced in our daily life in trigonometry in architecture. So in this situation, architecture, he wants to build a roof. So he wants to know the distance of the roof. Okay, for the first question, how long is the roof needed to cover the walkway, and how much is the angle between the wall and the roof in degrees and minutes? To solve the first question, we have to draw it in a triangle. Okay, when we draw the question in a triangle, we can see that we have to search for the hypotenuse. To search the hypotenuse values, we have to use this formula, which is a square at b square square root, and we have to replace it with the values, which is 0.8 square at 2.4 square root, and when we calculate this, we will get 2.53 meter. And for the second question, we have to use this formula to find the angles between the wall and the roof in degrees and minutes. Okay, the formula is tan angle equals to opposite per adjacent, and we already know the values of opposite and adjacent. So the value of opposite is 2.4 and the value for adjacent is 0.8. And to know the value of angle, we have to bring the tan to the right side, so it will become negative. So tan -1, 2.4, 0.8, and when we calculate this, we will get 71.57. this answer is in a decimal. So to get the answer in degree and minutes, we have to use calculator and we will get 71 degree 33 minutes. So this is the answer for the
To summarize what we have learned today, trigonometry is one of the oldest branch in math used in Arabic, Indian, and Euro civilization. Trigonometry works on all triangles, but right angle triangle is the most common one. Sometimes a right angle triangle can be found in other triangles. There are three sides in a triangle: hypotenuse, adjacent, and opposite. From these sides, we can use a formula in finding theta or angle based on the given info. So these are the following formulas. As the conclusion, trigonometry is very useful in architecture.